Hi, this is Mr. Derived, and I'm your physics teacher. So today starting with mechanics, and the classes we are focusing on will be from 3, from 4, from 5, and yeah, so we ordinary level, or those who are doing great, grade 9, grade 9, grade 8, 9, and 10. This lesson is for you. So mechanics is one of those key topics in branches in physics, which is like the core of physics. So in every mechanic, for you to get to understand mechanics well, it's always advisable to start with physical quantities to be to understand what are physical quantities. I believe by now you know actually um, these various instruments. For example, if I have this instrument like this, I think you can identify this, right? So this is a vernier caliper, and if you look at the instrument very well, you see there are numbers on it. You see numbers on it. What are the numbers for? If you look at it, you see something here, IN. What does it stand for? What will be? What will be if this IN is not here? How would this thing look like? So if you look at this, some of you have seen this is spring balance used to measure mass. So if you also look at these things very well, even if they're not visible, you see numbers on it. What are the numbers for? Why should they put numbers on it? Those are questions that need to come in your mind. Why should they put numbers on it? Why not just allowing the thing just like that? And so, and if you look at this digital meter, you see numbers and you see something at the end of it. Yeah, like small zero and an F. Yes. And so at times we start to say, why does all these things stand for? So what does this stand for? If you look at this one, this is what the stopwatch. If you look at it very well, I'll bring it closer. So you see that you see numbers on it too, and this number tells you different. It tells you time, and so this is used to measure time. And so I think you need to ask yourself, but why are the numbers? Why should they put some things there for you to? So that's why we need to study it, because those are the things that we need to be using in physics all the time. So you need to master them, and mastering them is very helpful for your understanding of physics, of mechanics, as we say. So it's very important. So this topic is for you to understand what are the building blocks. Physics stands on something. Every house stands on a foundation. So what is the foundation in physics? So physics has its own foundation, and this foundation is physical quantities. So physical quantities are like we call building blocks. Building blocks of physics. We cannot do without them. We cannot build it. We cannot do the house without foundation. Or we call them that the measurable properties. Measurable properties. Or features in physics. Measurable property means that they can be measured. And when you measure them, what do you use to measure them? You use measuring instruments in measuring them. You use measuring instruments in measuring them. And these measuring instruments, now before, you did not have measuring instruments. Like in the market, you go to the market, you want to buy Gary. What do they use? They use cups. They use a pan. Some people use even glass to measure. But one thing is very peculiar about these things that they use in the market is because if you look on them, they are not numbers. But the ones I've shown you here, you see numbers on them. So those are the difference between a measuring instrument and an estimated instrument. A measuring instrument is an instrument that has calibrations. But an estimated instrument do not have calibrations. So these numbers on it helps us to know the exact quantity. So if I come to buy, for example, like I have on this one, this one is very simple. Okay, I have on this one. If I say I'm measuring 2, all the time I can measure 2. I know where 2 is. But if this thing did not have numbers, I can say, okay, 2 was here. But later on, I can say, no, I thought it was here. So 2 will always be changing. It will not be always exact. That's why these numbers are there. So putting numbers on instruments is what we call calibrations. And these calibrations is the thing that defines a measuring instrument or differentiate a measuring instrument from an estimated instrument. And you see all the measuring instruments, they always have their units on it. You see IN, it means inch. We go to this one, if you look at if the numbers are visible, you see Newton and N, which means force. If you go to this one, you see it's unit there, 0 degrees Fahrenheit. Those are the units. Each instrument has its units on it. So you need to know their units, because if you don't know their units, then you will not able to know that it's a measuring instrument. Like the glass, if you go to the market to buy gari, they use it for gari and they use it for rice. So which unit is it measuring? You don't even know whether it's rice cup or it's gari cup. So they use for any of them. That's why you see an estimate. So physics has its foundation, which is physical quantities. And we say physical quantities are the building blocks, are measurable properties. So this measurable property is defined in magnitude. Take note, please. Is defined in magnitude as a physical quantity. Is defined in magnitude as a number plus a unit. Take note. A number plus a unit means that if I want to define a physical quantity, I must write a number 20 and I must write a unit. Let me say meters, for example. This one represents a physical quantity. It means I have a number, I have a unit. That's a physical quantity. So there are two types of physical quantity that we will see. That there are two types of physical quantity. There are two types of physical quantities. We have base or fundamental, and we have derived physical quantity. We have two, base or fundamental physical quantity or derived physical quantity. So what is base physical quantities? So a base physical quantity is a quantity that cannot be expressed into other physical quantities. So these are quantities that cannot be expressed into other physical quantities. They are independent. They cannot be expressed, to other physical quantities. And there are 7 in number. There are 7 of them. So we have length, we have mass, we have time, we have temperature, we have current. There are 7 is you have luminous intensity and amount of a substance, but at your level we'll just talk about 5. These 5 of them. So I always abbreviate these 5 as let Mr. Time take current. Sound nice, right? Let Mr. Time take current. So if you want to know the 5 easily, L is length. This M goes to mass, T time, this T temperature, and this one current. So let Mr. Time take current is an abbreviation that you can easily know the 5 base quantities. Let Mr. Time take current. So it's very easy to know. So there are 5 base quantities which cannot be expressed into other quantities, but other quantities can be expressed into it. Which now these other quantities now we call them what? Derived quantities. So derived quantities are quantities that can be replaced. This one. So derived quantities now are quantities that we can express into other that can be that they are formed or that they are formed or they are gotten or they are obtained by either dividing or multiplying one base physical quantities. So derived physical quantities are quantities that are obtained or gotten by multiplying or dividing base physical quantities. For example, we have velocity. It's a derived quantity. Force, pressure. These are derived quantities. We have density. How are they obtained? You get velocity is distance on time. So you divide distance is length. So you divide length on time, you have what? Velocity. So velocity is derived. You have pressure is force on area. So you are dividing force on area to have that. To have area, you need length times length. Force is mass times and speed. Mass times acceleration, which is speed on time. So you see, all of this comes from these 5. All of these units, these ones here, are coming from this. So we have 7 base quantities, but we are going to talk about 5: length, mass, time, temperature, and current. And we have the rest, which I have not mentioned, are all what? Derived physical quantities. So now, these quantities, what differentiate length, mass, time, temperature, and current from another? What differentiate them? We can pause the video and think about what differentiate them. What differentiate these 3 units or these quantities? It's what we call units. Unit differentiate one quantity to another. If I write this, how will you know? What's the difference? It's 2m, 2 seconds, 2 amperes, 2 kilograms, 2 degrees Celsius. Which quantity is it? So this is a physical quantity, 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 this is a physical quantity. This is 2 meters per second. All of them are physical quantities. But now how do you know that which one is which quantity? Is a unit, this one. How do you know is a unit? The unit tells you. The unit tells you. This man tells you. This man tells me that this man is length. This man tells me this man is time. This man here tells me this man is current. This man tells me that is mass. This one tells me that is temperature. And this man tells me that this man is speed. So the unit is the one that differentiates one unit, one quantity from another. And this was made possible by an international system that we call SI, the Conference System International Unit, SI unit. So they set standards, made some units to be standard for the whole world to use. So these units are set aside so that there should not be confusion. That if I see this unit, I know this is for length. If I see this one, it's for time. If I see this one, it's for current. If I see this one, it's for mass. So there will not be confusion in the world. That's what they set aside. So System International Unit was set aside to make units so that we can use them so that everybody will have the same, working on the same level. Right. So each quantity, so at the end of this lesson, you're supposed to know each quantity, each base quantity and its unit. Very important. And its measuring instrument. Which instrument is used to measure this unit? Right. So for example, let's do it like, okay, if I can do this, so you can have, so if you can draw the table like this, I'm trying that. Let's see. You have quantity. So you can have, first one, you have length. What's the symbol? It's L. What's the unit? The SI unit is what? Meter. What's the symbol? Small m. Look at how I'm writing it, small m. And what is the instrument? Instrument. You have ruler, vernier, caliper, micro, screw gauge, and there are many, right? Now we go to the next. Mass. What's the symbol? Capital M. What's the unit? Kilogram. And then what's the symbol? And what you have a balance. The next we have time. You have T. You have seconds. You have small s. You have watch, stopwatch. And then you have the next one. You can have temperature. So what do you have? You have T, or you have theta. You have Kelvin. Look at the symbol, small letters. You have capital K, which is a symbol, and then you have thermometer. And lastly, we have current. You have I. You have ampere, capital A, and then you have ammeter. So these are the different units. You can pause the video and copy down this. Very important for you to know this because they will always ask in your exam. And then one thing, important thing in writing unit is the rules in writing unit. Very important, rules in writing unit. When the unit, all units are written in small letters. When you're writing it in full, when you're writing unit in full, they are written in small letters. Take note. Look at it very well. They are written in small letters. And their symbols are also small letters, except it's named after a person. For example, we have this one, ampere, is small letters. But now the symbol is capital A. Why? Because this one is named after a person, so we have capital A. Now this man is Calvin. It's small letter K, but the symbol is capital K because it's named after a person. Small letter, small letter, small letter, small letter, small letter, and small letter. So the units are always written small letters, except capital letters, except is the name of a person. Right. Good. So this is explanation on physical quantities for ordinary level. Thank you for watching, and if you want more understanding and want more questions on how to do this, we can give you more questions. You can join our study group to get more questions or get more understanding of these topics. But if you want me to do more videos on how to explain certain concepts on this aspect, you can put in the comment section. I'm going to explain and give more videos on how to do those various concepts that you do not understand. Thank you for watching.